Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss permutations and combinations. In this chapter, we are going to discuss the sums in the exercise 7.3. Question numbers 1, 2, 3, 5, 6, and 7. In the previous class, we have discussed the concepts of exercise 7.3. I hope you have understood the concepts of exercise 7.3 well. Haven't you, my dear children? Right. Now, are you ready to listen the class? Right. Before going to solve the sums in this exercise, let us recall some points. See here, note. In which case we use permutations concept. In this note, we are going to discuss in which case we use the concept of permutations. See here, in problems on permutations or arrangements, both number of things and their order is important. Both are important points. So we must have to apply permutation formulae in the following types of problems. So the following types of problems we use permutation formulae. What are the types of problems? Let us see what are the types of problems. Okay, see here, first type, word problems, words framed, words formed by letters. And second type of problems, numbers formed by digits. This is the first type of problems, words formed by letters. And second type of problems, numbers formed by digits. Next, third type of problems, seating arrangements. In this case also we use permutations formulae. Similarly, signals and letters and envelopes. In all these cases we use permutation formulae. And tossing of coin or coins. And finally, throwing a die or dice. In all these type of problems, we use permutation formulae to find the number of arrangements or to find the number of permutations. Okay, my children, right. Remark. What is the remark? Let us see this point. All the questions of exercise 7.3 are questions on permutations only. All the questions in this exercise 7.3 are based on the concepts of permutations. Okay, my children, right. So let us recall what is meant by permutation. This is a definition of a permutation. The different arrangements which can be made out of a given number of things or objects, by taking some or all at a time are called permutations. Understood this point, my dear children? This is the definition of permutation. Permutation is different arrangements which can be made out of a given number of things by taking some objects or all the objects at a time. These are called permutations. Okay, my children, right. See here, notation. What is the notation to denote permutations? See here, this NPR. Here, R should not be written in the same line. It should be written as a subscript or P of N comma R. This is not ordered pair. This is not a point and this is not an ordered pair. Don't be confused with a point in the Cartesian plane. You denote a point in the Cartesian plane like this, but here this is not a point. Permutation of n objects taking r objects at a time. Okay, my children. But in general, we use this notation only. Most of the cases, we use this notation, NPR. Are you observing this laser point, my dear children, on the screen? Yes, this NPR, not this one. This is a very rare case. But you should remember this notation also to denote number of permutations of n objects taken or at a time. These two notations denote the number of permutations of n objects taken or objects at a time. And NPR, this is the formula. To find the value of NPR, what is the formula? N factorial by n minus r factorial. You have to remember this formula also. Here we have defined the value of NPR in terms of factorial notation. Okay, my children, right. Now come to the question number 1. Question number 1. In the exercise 7.3, question number 1. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? In the first exercise, you have found the number of 3-digit numbers which are formed by using the digits 1 to 9 by using fundamental principle of counting. Yes or no? Do you remember that method, my dear children? Yes. Here also we can use the same method, but here we use NPR notation. In this exercise, we use most of the case NPR notation. Okay, my dear children? Right. Now come to the solution. What is to be done here? We have to form a 3-digit number. We have to form a 3-digit number using the digits from 1 to 9. That means the order of the digits also matters. It is also important. Okay. Here we are going to form a 3-digit number using the digits from 1 to 9. In the first exercise, what you have done, you have taken 3 empty boxes to denote a 3-digit number. Yes or no, my children? Right. Let us take that empty box here also. Hence, there will be as many 3-digit numbers as there are permutations of 9 digits taking 3 digits at a time. We have taken 3 digits at a time out of 9 digits. The number of permutations of 9 digits taken here, only some objects are taken. Total number of objects is 9. Out of these 9 objects, we have taken 3 objects at a time. In the previous slide, we have denoted this sentence in the form of a notation. What is that? NPR. Here N means 9, R means 3. Total number of objects, total number of digits is 9, and we are forming a 3-digit number. So we have chosen 3 digit at a time. Understood this point, my children? Right. So for that we have taken 3 empty boxes like this. Are you observing this right side? I am showing the 3 empty boxes to denote a 3-digit number. In these 3 empty boxes, the first empty box stands for hundreds place, and the second empty box stands for tens place, and the third empty box stands for units place. So How many empty boxes are there here? 3 empty boxes to denote a 3-digit number. So in how many ways these 3 empty boxes can be filled by these 9 digits? Yes, we denote it by N9P3. We denote this sentence as NP3, 9P3. So required number of 3-digit numbers is equal to 9P3. Here we are not using fundamental principle of counting. Indirectly we are using that only, but physically we are not showing that. Okay. 9P3, we denote this sentence. We are filling these 3 blanks by these 9 digits. This can be done in 9P3. Please remember this notation, my children, in which case we use this notation. If there are 3 empty boxes, if you have 9 objects, 9 digits in your hand to fill these 3 empty boxes, in how many ways it can be done? 9P3. Okay, my children, right. How do you find the value of 9P3? There is a simple technique. Not using the factorial notation. I am not using the factorial notation to find the value of 9P3. Then how to find the value of 9P3? Here in the subscript, what is the number here? 3. In the subscript of this notation, what is the number here? 3. So we have to write 3 factors. We have to write 3 factors starting from this number 9. Both numbers are important. This subscript number denotes how many factors should be written. This number denotes from which number we have to start, and we write the factors in the descending order. So starting with 9, we write the 3 factors in the descending order. The natural numbers, we write the natural numbers starting from 9. So 9 into 8 into 7. Understood this point, mentioned on how to find the value of 9P3. We started with 9. So here we wrote the natural numbers in the descending order, and we wrote 3 factors. See here, this is the first factor 9, second factor is 8, and the third factor is 7. Understood this step, my dear children, how to find 9P3? Yes. Then we multiply these 3 numbers. What did you get here? 504. So finally this is the number. Denote the number of 3-digit numbers formed by using the digits from 1 to 9 if no digit is repeated. Okay, my children. Hence there are 504 3-digit numbers formed by using the digits from 1 to 9. No digit is repeated. Understood this question, my dear children? Right. Shall we go to the next question? Right. Now come to the question number 2. See the question number 2. How many 4-digit numbers? How many 4-digit numbers are there with no digit repeated? Here also same type of question here as we have done in the first question. Here also same type of question. Okay, my children. But in the first question they have mentioned the digits from 1 to 9. Actually, what are the digits? Do you remember what are the digits? Yes, 0 also 1 digit. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All these are called digits. Okay, my children. Right. Now come to the solution part. There are 2 methods to solve this question. After watching the 2 methods, you can follow any method. Which method is easier to you? You can follow any method. Okay, my children. Right. Now I am going to explain the first method. Right. See here. How many digits should be there in the given number? 4-digit number. So we have taken 4 empty boxes. As we have done in the first exercise, here also we are taking 4 empty boxes to denote a 4-digit number. In this 4-digit number, what is this first place denote? Thousands place. The second empty box denote hundreds place. Third empty box denotes tens place, and last fourth empty box denotes units place. Okay, my children. So thousands place, next empty box hundreds place, next empty box tens place, and next empty box units place. Understood this one, my dear children? Right. Now come to the question. The thousands place of this 4-digit number. The thousands place of the 4-digit number is to be filled with any one of the digits from 1 to 9. Yes or no, my dear children? Can you fill the thousands place by 0? Then is it said to be a 4-digit number? No, not at all. So this thousands place, this first empty box can be filled by any one of the digits, 1 to 9. 0 cannot be included. Understood this sentence, my dear children? Then in how many ways this empty box can be filled from the digits 1 to 9? Yes, this operation can be done in 9 ways. Yes or no, my dear children? Therefore, we are writing that sentence. Therefore, the number of ways in which thousands place can be filled is 9. Understood this sentence, my dear children? We are filling this thousands place with the any one of the digits from 1 to 9. So this thousands place can be filled in 9 ways. This is over. Then how many places are there? Remaining 3 places. 3 empty boxes are there. So how many digits are there in our hand? After filling 1 digit in this thousands place, how many digits will be left? Yes, don't be confused. 0 also included. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But out of these digits, 1 digit already used. Here no digit is repeated. So in this case, how many digits will be there in our hand? Yes, 9 digits will be there in our hand. 9 digits are there in our hand. We have to fill 3 empty boxes. In how many ways this operation can be done? Yes, 9p3. Understood this point, my children? After filling the thousands place, again we have 9 digits in our hand. So by using these 9 digits, we can fill these 3 empty boxes in 9p3 ways. Here there are 2 operations, filling the thousands place and filling these 3 empty boxes. So we use here fundamental principle of counting at last. Therefore, the hundreds place, tens place, and units place, these 3 places can be filled. These 3 places can be filled by any one of the digits from the digits 0 to 9. From 0 to 9, we have to fill these 3 empty boxes. But already 1 digit filled. So how many digits will be there in our hand? 9 digits. If you count the number of digits from 0 to 9, total 10 digits are there. Yes or no? Out of these 10 digits, we have already used 1 digit to fill the thousands place. So we have 9 digits in our hand. However, the digits cannot be repeated. This is also important point. The digits cannot be repeated in the 4-digit numbers. And the thousands place already filled. The thousands place is already filled, already occupied with any one of the digit, 1 digit. Understood this sentence, my children? Right. The hundreds place, tens place, and the units place, 3 empty boxes are there to be filled. These 3 empty boxes, these 3 places, hundreds, tens and units place is to be filled by the remaining 9 digits. Yes or no, my children? There are 9 digits will be left in our hand. Therefore, there will be as many such 3-digit numbers as there are permutations of 9 digits, 9 different digits, taking 3 at a time. Understood this sentence, my children? We are taking 3 digits at a time out of 9 digits. In how many ways this can be done? Yes, number of such 3-digit numbers, is 9p3. Understood this 9p3, my children? Right. Now you know how to find the value of 9p3. Previously I told you, first we have to focus on the subscript number. Here 3 is there, so we have to write 3 factors starting from 9, and we write the natural numbers in the descending order starting from 9. Then tell me the value of 9p3. Yes, 9 into 8 into 7. Previously also we found the value 504. Okay, my children. So we have filled the 3 empty boxes also. We have filled these 3 empty boxes. This operation and this operation. We divided total 4 operations into 2 operations only. Filling the thousands place and filling the remaining 3 places at a time. Understood this point, my children? Right. Thus, by multiplication principle, the required number of 4-digit numbers, is equal to 9 into this 9. We have already found this thousands place can be filled in 9 ways. So 9 into this 504. 9 into 504. That is equal to 4536. These many 4-digit numbers can be formed by using the digits without repetition. Understood this question, my children? Right. We can find the same number in the second method also. I'm going to explain second method also. Okay, my children? Right. See, this is second method. So this is the question. Now come to the solution. This is the second method. How to find the number of 4-digit numbers when the no digit is repeated. Okay, my children. Here we use permutations concept. We are not going to take any empty boxes. Directly we use permutations concept to find 4-digit numbers. Right. See here, first we have to remember this formula. Total number of r-digit positive integers formed by using n digits. If there are n digits in our hand, 0 is also included in the given digits. If 0 is also included, if we want to write a r-digit positive integer which no digit is repeated, is equal to npr minus n minus 1 pr minus 1. We use this formula directly. npr minus n minus 1 pr minus 1. Now tell me, my dear children, how many digits are given here? How many digits are given? Yes, 10 digits. Yes or no? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all 10 digits. So n is equal to here 10. Then what is r here? How many digit number are required? 4-digit number. So r means 4. N means 10. R means 4. We substitute n is equal to 10 and r is equal to 4 in this formula. Then automatically we get number of 4-digit numbers. Okay, my children, right. Given digits. What are the given digits here? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Count here how many digits are given? Total 10. Means here n is equal to 10. Understood this point, my children? Here n is equal to 10. 0 is also included. 0 is also included in the given digits. Observe this point, my children. Here in the given digits 0 is also included. So here what is n here? Yes, n is equal to number of given digits or number of digits given. Number of digits given is equal to 10. Yes. Now which type of numbers we are going to frame? Yes, 4-digit number. So we have to write 4-digit numbers. So what is here? 4 denote, yes, R. Here R value is 4. Here number of digits in the required number. How many digits should be there? 4 digits. So R is equal to 4. So like this we have to find n value and R value. N is equal to 10 and R is equal to 4. After finding these two values, we substitute these two values in this formula to get the number of 4-digit numbers when the no digit is repeated. Therefore, the required number of 4-digit numbers is equal to NPR minus n minus 1 P R minus 1. I told you we use this formula. What is n? What is R here? 4. So that is equal to NPR minus, again I wrote here, that is equal to n is equal to 10 and R is equal to 4. So 10P4 minus 10 minus 1. What will get here? 9. So 9P4 minus 1, 3. Understood this step, my children? 10P4 minus 9P3. Right. Now we are going to find the value of 10P4 and we find 9P3 value separately. Do you remember how to find the value of 10P4? Yes, we have to write 4 factors. Starting from this number 10 and write the natural numbers in the descending order. Okay, my children. So how do you find? That is equal to 10 into 9 into 8 into 7. Understood this first number? Minus, similarly 9P3. Starting from 9, we write the natural numbers in the descending order up to 3 factors. 3 factors only. So 9 into 8 into 7. After expanding this notation, we find the value of the first term and the value of the second term. Okay, my children? Right. That is equal to, the value of the first term is 5040 and value of this second term 9 into 8 into 7 is 504. Now simplify these two numbers. Finally we get 4536. In the previous first method also you got the same number. Understood these two methods, my dear children? Right. So you can follow any method. This is a formula based method, and in the previous method, first method, we used permutations concept as well as fundamental principle of counting concept also. Okay, my children? Right. Shall we go to the next question? Right. Now come to the next question. Question number 3. How many 3-digit even numbers? How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated. Understood this question, my children? We are going to find the number of 3-digit even numbers. So which type of numbers should be written 3-digit? So we have to take 3 empty boxes. Okay, my children, come to the solution part. We have to form 3-digit even number. We have to write 3-digit even numbers using the given digits. How many digits are given here? 6 digits. 1, 2, 3, 4, 6 and 7 without repetition. This point is also very important. Without repeating the digits. Understood this point, my children? Right. So to do this one, first we are taking 3 empty boxes to denote a 3-digit number like this. What is this first empty box denote? Hundreds place. Second empty box denotes tens place, and third empty box denotes units place. Okay, my children. See here, hundreds place, next tens place, next units place. So what is the question here? We have to write even number. What is meant by an even number? If a number ending with 0, 2, 4, 6 or 8. Any one of the digits should be in the units place. So in the given digits, what are the even digits? 2, 4, 6. These 3 digits only even digits. So first we focus on filling the units place, this empty box. We have done this type of question in the first exercise also, my children. But we are using here permutations concept. Okay, my children. Right. Then first we focus on filling the units place. Then units place can be filled. Units place can be filled in 3 ways by any one of the digits 2, 4 or 6. Only these 2 or 3 are even digits in our hand to fill this units place. This can be done in 3 ways. Okay, my children. Right. So this is over. We have filled units place. Then how many empty boxes are there? Yes, 2 empty boxes to be filled. That is tens place and hundreds place. So here no digit is repeated. So one digit is already used in this units place. Then how many digits will be left in our hand? Out of 6 digits, 1 digit already used. Then how many digits will be there in our hand? Yes, only 5 digits. We fill these 2 empty boxes by the 5 digits. In how many ways can be done that operation? Yes, 5p2. 5p2. How do you denote that operation? Yes, 5p2 ways. Since the digits cannot be repeated, here no digit is repeated in the 3-digit numbers, and units place is already filled, already occupied with a digit. Already we filled the units digit, which is even. Then what are the places left here? The hundreds place and tens place is to be filled by the remaining. How many digits are remained? 5 digits are remained. In how many ways this can be done? 2 empty boxes, hundreds place and tens place should be filled with 5 digits. So number of permutations of 5 digits by taking 2 at a time. Understood this point, my children? So therefore the number of ways in which hundreds and tens place can be filled with the remaining 5 digits remaining 5 digits is the permutations, is the number of permutations of 5 digits, 5 different digits taken 2 at a time, taken 2 digits at a time. How do you denote this sentence? The number of permutations of 5 different digits taken at a time. Yes, 5p2. Okay, my children, remember this point, how to denote a sentence. So the number of ways of filling, the number of ways of filling hundreds and tens place is equal to 5p2. Okay, my children, understood this step, right? Now come to this point. How do you find the value of 5p2? Do you remember how to find the value of 5p2? Yes, we had to write two factors. Previously I told you we had to focus on subscript. Here what is the number in the subscript? 2 is there. So we had to write two factors. Starting with which number? Here 5 is there. We have to start with 5 and write the natural numbers in the descending order. Understood this point, my children? Right. That is equal to 5 into 4. That is equal to 20. So here the entire job, the entire work is divided into two operations. The first operation is filling the units place and the second operation is filling the remaining two empty boxes. So by the fundamental principle of counting, therefore counting multiplication principle, therefore by the multiplication principle, the number of 3-digit even numbers, the required number of 3-digit even numbers or 3-digit numbers is equal to 3 into 20, because here 3 ways, here 20 ways, so 3 into 20. Understood this step, my dear children? Right. That is equal to 60. So we can write 60 3-digit even numbers by using the digits 1, 2, 3, 4, 6 and 7. Understood this question, my dear children? Right. Shall we go to the next question? Right. Now come to the next question. Fifth question. Here I am not explaining the question number 4. Do the question number 4 as homework. Will you do that question number 4 as homework? Will you try it? If you have any doubt in doing the question number 4, please feel to ask your doubts and get your doubts clarified. Now come to the question number 5. From a committee of 8 persons, there are 8 persons are there in a committee. In how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? Here there are two positions, namely vice chairman and chairman. Two positions are there. We have to choose 2 persons. Out of 8 persons, we have to fill these two positions, chairman position and vice chairman position, assuming that one person cannot hold more than one position. Understood this question, my children? Right. Come to the solution part. We have to choose a chairman and a vice chairman. You have to choose a chairman and a vice chairman from a committee of 8 persons in such a way that one person cannot hold more than one position. Understood this sentence, my dear children? We have to choose a chairman and a vice chairman from a committee of 8 persons. How many numbers are there? How many persons are there? 8 persons are there. How many positions are there? 2 positions, namely a chairman position and a vice chairman position. So to denote these 2 positions, let us take 2 empty boxes. See here, my dear children, I have taken 2 empty boxes. These 2 empty boxes denote, one is chairman position and Another blank is vice chairman position. So two empty boxes are there. In how many ways we can fill these two empty boxes? By 8 persons. Here number of persons in our hand is 8. Here we have to fill these two empty places. We have to fill these two positions. In how many ways we can do that operation? 8. Yes, 8p2. Understood this point, my children? Right. Here the number of ways of choosing a chairman and a vice chairman. Here the number of ways of choosing a chairman and a vice chairman is the permutations of n different persons and different objects taken two at a time. How do you denote this sentence? Permutations of n different objects taken at a time. Yes, 8p2. Understood this point, my children? Right. Thus, required number of ways is equal to 8p2. Understood this step, my children? Right. Now come to this question. We have to find the value of 8p2. How do you find the value of 8p2? Yes, previously also I told you we had to focus on the subscript of this notation. What is the number in the subscript here? 2. So we had to write two factors. Starting with which number? Here 8. Starting with 8, we write natural numbers in the descending order. Okay, my children, please remember this point. That is equal to 8 into 7. Then what is the value of 8 into 7? 56. So this is the number of ways of choosing a chairman and a vice chairman, assuming one person cannot hold more than one position out of 8 persons. Understood this question, my children? Right. Can we go to the next question? Right. Now come to the next question. Question number 6. Find n if n minus 1 p3 is to np4 is equal to 1 is to 9. Here the relation is given like this: n minus 1 p3 and np4. How it is given? N minus 1 p3 is to np4 is equal to 1 is to 9. In that case, what is the value of n? Okay, my children? Right. Now come to the solution part. Given, what is given here? N minus 1 p3 is to np4 is equal to 1 is to 9. Do you remember this point, my children? A ratio can be written as a fraction. Do you remember that point? A is to B. Suppose a ratio is given as A is to B. How do you write it as a fraction? Yes, A by B. So this implies we are writing this ratio in the form of a fraction. So n minus 1 p3 is written as numerator, and the second number np4 is written as denominator, is equal. Same is applied in RHS also. 1 is to 9 can be written as 1 by 9 because A is to B is equal to A by B. Understood this step, my children? Right. Now come to the numerator here. What is the subscript in the numerator here in this notation? 3. So we have to write this value starting with this number n minus 1, and why we write the natural numbers in the descending order. Previously also I told you we use the same point here. That implies we start with n minus 1. So n minus 1 into n minus 2 into n minus 3 whole divided by here np4. What is the subscript here? 4. So here we have to write 4 factors in the denominator starting with n. So we have started with n and we wrote the natural numbers in the descending order. So n into n minus 1 into n minus 2 into n minus 3. That is equal to, we wrote RHS as it is. Understood this step, my children? Right. Now can you simplify this? Can you simplify this equation? Yes. So here n minus 1, n minus 1 gets cancelled. Here n minus 2, n minus 2, n minus 2 gets cancelled. N minus 3, n minus 3 gets cancelled. Yes or no, my children? Right. Then what is the next step? This that implies 1 by n is equal to 1 by 9. 1 by n is equal to 1 by 9. Understood this step, my children? Right. Then what is the value of n? Yes, that implies n is equal to 9. Understood this question, my children? Right. Can we go to the next question? Right. Therefore, n is equal to 9. Okay, my children? Right. See the next question. Question number 7. Question number 7. Find or if here there are two parts, but here I am explaining only first part of this question number 7. Please try the second part of this question number 7 as homework. Will you do the second part of this question as homework, my dear children? Right. What is given here? 5pr is equal to 2 into 6pr minus 1. In the previous question, we have found n value, whereas in this question, we are going to find r value. Okay, my dear children? Right. Now, come to the solution part. Come to the solution part. What is given here? 5p6, 5pc, 5pr is equal to 6pr minus 1. This is a given equation. 5pr is equal to 6pr minus 1. In the previous question, to write the value of npr, we focused on the number in the subscript. But here, no number is given. Here, r is given as a subscript. In this case, we use the formula npr is equal to n factorial by n minus r factorial. In the first slide itself, we have defined npr in the factorial notation. So we use that factorial notation here. So 5pr is equal to 5 factorial by 5 minus r factorial is equal to 2 into 6pr minus 1. 6 factorial by 6 minus of r minus 1. Finally, you get 6 minus r plus 1 factorial, because npr is equal to n factorial by n minus r factorial. Here we are using factorial notation to expand this npr notation. Understood this step, my dear children? Right. That implies in the numerator, what is there? 5 factorial. What is the value of 5 factorial? How do you find 5 into 4 into 3 into 2 into 1 by we write denominator 5 minus r factorial as it is equal to 2 into, here in the numerator 6 factorial is there. How do you find the value of 6 factorial? 6 into 5 into 4 into 3 into 2 into 1 by here 6 plus 1. What will you get here? 7 minus r factorial. Understood this step, my dear children? Right. Now, if you observe the numerator, 5 is there here. We can strike out 5 on both sides, 5 on both sides, 4 on both sides, 4 gets cancelled on both sides in the numerator. Here 3 is there in the numerator. We can strike out 3 on both sides. Here 2 is there in the numerator on both sides. So we can strike out 2 also in the numerator on both sides. And finally, what will you get in the numerator? Yes, this implies in the LHS, we get in the numerator 1 by 5 minus r factorial is equal to, in RHS, in the numerator 2 into 6 is left, so 2 6 are 12 by, in the denominator 7 minus r factorial. We are expanding 7 minus r factorial. How do you expand a factorial notation? Right, we start with this number 7 minus r. Next 7 minus r minus 1, 6 minus r we get. After that again we have to subtract one number from this number, so 5 minus r. We are stopping this factorial expansion by this number, so immediately we keep factorial notation. When and where you are stopping a factorial notation, immediately after that number we keep factorial notation. Understood this point, my children? Please remember this point. Now here in the denominator on both sides 5 minus r factorial is there. So we can strike out 5 minus r factorial on both sides in the denominator. Okay, my children. Then finally what will you get? Yes, this implies 7 minus r into 6 minus r is equal to 12. By cross multiplication we get 7 minus r into 6 minus r is equal to 12. Okay, my children, from this equation we had to find the value of r. Okay, my children, right. This implies multiply these two factors. 7 into 6 42, 7 into minus r minus 7r, minus r into 6 minus 6r, minus r into minus r plus r square. Distributive property we used here in LHS, distributive property, and we got these four terms in LHS is equal to 12. Okay, my children, understood this step? Right. This implies r square minus 13r plus 30 is equal to 0. By simplifying the terms and writing the terms in a particular order, we get this equation. R square is there. By simplifying minus 7r minus 6r, we get minus 13r. If you transpose 12 to LHS, 42 minus 12, we get plus 30. Understood this step, my children? Right. In this stage, if you observe this equation, it is a quadratic equation in R. It is a quadratic equation in R. So we have to solve this equation by using the splitting the middle term method. We are using the splitting the middle term method. So we are writing first term r square as it is. We are splitting minus 13r as minus 10r minus 3r, and we write the last term as it is plus 30 is equal to 0. Understood this step, my children? Do you remember how to use splitting the middle term method to factorize a quadratic expression, a quadratic polynomial in LHS is there? We are splitting into two factors by using the splitting the middle term method. Okay, my children? Right. This implies, if we observe in the first two terms, r is a common factor, so we have taken r outside, so r minus 10 minus 3 is a common factor from the last two terms, we have taken minus 3 outside, so minus 3 into r minus 10 is equal to 0. Again, if we observe here, r minus 10 is a common factor, we take out r minus 10 as common factor, then we get r minus 10 into what is left here, r minus 3 is equal to 0. Understood this step, my children? Right. This implies r is equal to 10 or r is equal to 3. Here we got two values for r, but here a small trick is there. Here 5pr is there, so this r value should not exceed this big number, this r value should not exceed this number, but we got here r is equal to 10, so this 10 is exceeding this number, more than this number, so we should not consider r is equal to 10. We have to take r is equal to 3 only. In the notation NPR, this r value should not exceed the value of n. Remember this point also, my dear children. But we will take only r is equal to 3, as 0 is less than or equal to, r is less than or equal to 5. So here 5. This r value should not exceed 5. Okay, my children, understood this point, my children? Right. Therefore, r is equal to 3. Like this, you have to find the value of r in the second part of this question also. Will you try the second part of this question, question number 7 as homework? Please try that question also. If you have any doubts in solving the second part of this question number 7, please feel free to ask your doubts and get your doubts clarified. Okay, my children? Right.